this is for 8.9 today, called Law of Sines. And so the main idea for today, and what we'll see tomorrow as well, is we don't always have a right triangle. We work with any type of triangle, and if we don't have right triangles, then we need to find another method, because right triangles can use all those prior methods that we did before break, which include Pythagorean theorem. We have special right triangles, and then we have sine, cosine, tangent. That's called trig ratios. And then we did angle of elevation and depression, which kind of is the same thing as trig ratios. It's just in context. And then finally, we got to inverse trig right towards the end, right before break. And we had that quiz over both angle of elevation, depression, and inverse trig. So this is kind of everything you already know. In addition to that, I'm going to add the triangle sum theorem, because that's something we knew from before that helps us find all the missing angles in a triangle. That's for any triangle, but we know if we have a right triangle that the other two angles have to add up to 90 as well. So this is everything we already did, but this was all for right triangles. We were able to do all of this for right triangles. But if I see a diagram like I'm about to here in this launch for this triangle, it is not a right triangle. It's definitely not, because it shows us a 110-degree angle, which is obtuse. And so we'll kind of read through what this is asking us for, but we need to keep in mind that we can't just use any of these methods right off the bat. We may have to try to kind of alter this triangle and try to then make it a right triangle so that we can possibly use it, because right now you haven't been introduced to this new option, which is called law of sines. So it says a surveyor needs to find the distance BC, so I'm going to call this X, across a lake as a part of a project to build a bridge. The distance from point A to B is 325 feet. They've already labeled that for us. The measurement of angle A is 42 degrees, and the measurement of angle B is 110 degrees, also labeled. I'm not going to find C just yet, but if we needed to, we know we could have. We're going to stick with just what's here. What would be the distance of BC across the lake to the nearest foot? So what I can't do here is I cannot do like sine, cosine, or tangent with one of these angles, because I don't have a right triangle. So I can only do that when I have a right triangle. I can't do Pythagorean theorem, because again, no right triangle, and I don't even have a second side, and I can't really use any other method here. So here's where, if I was to be creative, what if I wanted to create some right triangles so that I could drop down this segment so that it created right angles on this side and this side. I can always draw a height in anywhere that's called an altitude. So I just drew an altitude in, and I don't know that exactly where this side length is going till, because I don't know what this whole measurement is, but I do know a little bit about the angles now. So let's see, if I was to draw this triangle here off to the left, I'm going to kind of draw it similar orientation. There's the right angle. I have 42 degrees here. And now, if this is 90 and this is 42, we know that this angle in here would be 48 degrees. It's no longer that full 110, but if this part is 48, then I can look at my second triangle here. It's a little bit of a longer triangle, oops, like this. And right angle is here. Well, this top angle in here then needs to be 110 minus 48, which is 62 degrees. Okay, so this 62 degrees is right here. So that's all I know so far. As far as the measurements of the sides, I do know this 325 goes right here, 325 feet. And that's about it, because I don't know anything in this triangle yet, but hopefully I'll find some of the missing sides. So what I do know here is, in order to find, I eventually need to find this X. Right, this is X right here that I've labeled as BC. It's in this triangle here off to the right. And I don't know what X is. I don't know what any of the sides are right now. I just know that this is 62. So if I can just find one side, which it would help if I knew this side, because it's a common side. These are the exact same sides, that altitude that we can call B. This is letter B if you do wanted to like label it, and I could call this like D. So this is BD. That same altitude is BD. This could be letter C here. So now I want to find BD. So if I look at this triangle, I can find BD. I'm going to use this 42 degrees with opposite, and this side here is the hypotenuse because it's across from the right angle. So that means I'm going to start with sine of 42 degrees is equal to the opposite, which was BD, which I don't want to call X, I'm going to call Y here, and divide it by 325. And when I solve this, you guys know we multiply by 325. We'll grab our calculator and type it in, and that comes out to approximately, for Y, 217.4674. And I'm keeping a bunch of numbers after the decimal on purpose. I know at the very end we're going to have to round to the nearest foot, but right now let's keep it not rounded. Don't round to like 217 right now because that's too rounded and it's going to change your final answer too much. So then we're going to now get closer and closer to finding this X now, because this 217 is, whoops, let me draw it like this side right here, right? This is BD. Okay, so now if I think of what I'm looking for, this 62-degree angle, I'm going to use my hypotenuse is X, and this is my adjacent side. So I'll use cosine of 62 is equal to 200, this answer I just got, 217.4674. If you want to round to like 47, that's fine too. And then divide it by X, which is what I'm looking for. This is BD. Use my, to solve this on a calculator, remember you're just doing 217.4674 divided by cosine of 62. That's how you type it into the calculator to help you find X, and that comes out to approximately 463.22. Now it's okay to round to the nearest whole number, which would be BC equals 463 feet. So we still found a way to figure out this missing side, even though it wasn't a right triangle to begin with. We had to create some right triangles, but that's a lot of work to do every single time. There maybe could be a shortcut, which is where law of sines comes in. Okay, so this thing called law of sines, and you don't have to necessarily memorize this because it will be provided to you on every, well, you don't have any more quizzes, but it will be provided to you on the test. It'll be written just like I'm about to write right now. So this is what law of sines looks like. It says sine of a capital A, or whatever angle measure like your triangle might have. In our case, we're using A, B, and C, and it divides it by the side across from angle A. Notice there's a lowercase a sitting right across from it. Okay, then it's going to set it equal to sine of a capital B. So now looking at this angle next and saying, okay, go across from this this capital B, you see a lowercase b for that opposite side. And then finally, it even does it with the last angle, sine of C is equal to, or divided by lowercase c. Just notice that the capital letters are your angles, the lowercase letters are your side lengths. Now, every triangle you see might not be drawn this way, like labeled with A, B, and C, so you could either label it that way, you can kind of relabel whatever you see, or just know that the main idea for law of sines is it's saying take sine of an angle and divide it by the side across from it, and then set it equal to sine of another angle and the side across from it. But you're not going to have three fractions when you actually use law of sines. You're going to pick two at a time. So either those two, or the first and the last, right? So you're going to have to look at the diagram to help you decide what is it that I'm looking for to help me use law of sines. And so when you have only, for example, two of the fractions set equal to each other, it could be these two, it could be those two, and so on. You're going to have all three of these, or 3 out of 4 of the variables filled in with numbers. Like you might have 2 angles and 1 of the side lengths. You might have 1 angle and 2 of the side lengths. It just depends what your diagram is showing you, but you can't have more than 1 unknown when you're working with a fraction, like these two fractions, these ratios. And then what we're going to do is we're going to cross multiply and solve until we have an answer for whatever our unknown is. So this is law of sines. Again, you don't have to technically memorize it, you just have to know how to work with it. So we're about to practice our first example down here, and then you'll have practice time with homework, or you can even do the practice on the next page. That's all good examples of the same thing. The main idea here though is that we're either looking for an angle measure or a side length. You can't be looking for both at the same time. So when I look at this, I have a capital B for the angle measure is 85 degrees. The lowercase b across from it is 9. Then we have capital A, this angle is 29 degrees. And it tells us to use law of sines. Now sometimes it might not tell us that. We just have to identify that this is not a right triangle. That's why I can't use my old methods anymore. I have to use this new thing called law of sines. Okay, so we have a capital A, and so you might say, well then what's the unknown? What am I looking for? Well, they literally told us too. It says find lowercase a here. We're looking for this, which makes sense because it's the side across from that given angle. So here's how this would look. You can start with sine of angle A, which is 29 degrees, then divide it by lowercase a because I don't know what lowercase a is. And then set it equal to sine of the next angle that I know, which is 85 degrees, and divide it by 9. That's what law of sines tells me to do. So far, this is my setup, and now from here, we're just cross multiplying until we can find an answer for a, lowercase a. Okay, so when I cross multiply here, I do have a lot of signs and things, but it's okay, we're gonna keep it going. The 9, which is a number, goes in front of the sine of 29 when I write it down. So 9 times sine of 29. Make sure you're not splitting up the word sine of 29. Remember, it's like a title, Mr. or and then the name. So it's like this is sine of that 29 that has to be there. 9 is just being multiplied to it. And then it equals a goes in front again of the sine 85. Okay, and this could have switched sides. It doesn't matter which one you write on the left versus the right, but now at this time we need to solve for a. I need a all by itself. And now I could grab my calculator and figure out what this whole thing is going to be, but before I do that, just so I don't have to round, I can keep it there for a second and just say, if I'm trying to get a by itself, I don't want this sine 85. I want to divide by all of the sine 85 so that it can cancel out on the right-hand side, but then it is going to be on the left. Okay, so it cancels out here, leaving me with just a. And here's where I grab my calculator and see what this will come out to. And you're literally typing it in exactly like you see it. And make sure you're in degree mode, which it is. So we have to type this in as 9 sine 29, close that parentheses after 29, divided by, and then sine again, 85. You can close the parentheses again, although it's not as important at the end here. And when you get an answer, whoops, hit enter and get our answer. It's about 4.38. This is what A is coming out to be. If I round to the nearest hundredths, which is what I was asked to do. The units, there were no measurements for units there, so we don't need to put anything, but you could put units if you wanted to, or if it's centimeters or inches or whatever. But that's all it is. That's what we're going to be doing with law of sines. It is, I would say, a little bit easier when you're looking for a missing side length, which is what we just did. It could have been the same problem, but if it changes letters, it's still done the same way. Like if we had the A's, like you were looking for A, you knew the angle for A, but then this was C and C. That's fine. It's still done the exact same way. You just need to know one pair of an angle and the side across from it. As long as you have that, you're looking for whatever's missing in the other pair. And you can only do one at a time. So like let's say we found A, but then the question says, well, can you find me C as well? Sure, I can. I would have to then find this missing angle C by subtracting from 180, and then use the law of sines again with across from C, right? And you could pick then, do I want to use sine of 85 or do I want to use sine of 29? I would probably stick to doing sine of 85 since that one was given to me, and that way I'm not making a mistake with doing the new answer I just found. If I made a mistake to get to A, then it would be a mistake to get to C then as well. Okay, so let's try one more. I know that this is it for the notes, but on the back page, it shows us how to find an angle measure, which is what I want to make sure we can do as well. Okay, and then we'll be all set. So on the back page, it starts off with this drawing in the length of this high side of the Leaning Tower of Pisa, and we're kind of trying to like figure out what the final answer will be. I'm not gonna figure out the final answer because you're gonna have to like do more than just law of sines for it. For right now, let's just practice just using law of sines to get to just that missing angle. What happens if we're missing an angle? What would we do then is what we're kind of trying to decide here. And actually what I might do is actually do a different problem than this one, because this one is actually needing a couple more extra steps to it. So what I'm going to do is actually go to the next page here, this problem set. This is all optional practice, but I just want to do one with you that you get to see how to find a missing angle instead of just finding a missing side length. Okay, so if I look at this diagram for number 2, or actually even number 1, let's start with number 1. I want to find, if I look at the angles that are provided, actually, I'm sorry, I cannot do this one until we have the next piece. Actually, we're going to do number 2. We need an angle on the side across from it. So notice I have that. I have an angle and I have the 123 that's across from it. So I want to then find this missing angle here because I have the side across from that. So here's what I would start with. Sine of, and again, notice how it's not A, B, and C. If you want to change it so it's A, B, and C, you can. I'm going to just do it without. So I start with the angle measure that I know, which is 115, divided by the side across from it, which is 123. Okay, and then I'm setting it equal to the other pair, which we don't know what sine of this angle Z is. We're going to find that eventually, and it's going to be, I'll call it Z, and we're going to divide it by the side across from it, which is 16. This is what we have to use law of sines for this time to help us find this angle. So here's what this looks like. I'm still cross multiplying, so I would do 123 sine of Z is equal to 16 sine of 115. And you could put Z in parentheses if you want, and you don't have to if you don't want to. Okay, now at this point, this is just a number. It's going to be a decimal number, but this side, I'm trying to get sine of Z all by itself because I can't get Z by itself. It needs to have sine with it. So I'm going to start by dividing by 123. So that this says sine of capital Z is equal to, and then I grab my calculator to see what is this whole big fraction going to be. So we have 16 sine of 115, close that parentheses, divided by 123. And this gives me a weird decimal, and you might think something is wrong at first, like maybe something went wrong. It is actually correct. You want to write down about 3 or 4 numbers after the decimal here, so I'll just round to 4. 0.1179 is what that would be. And the reason for that is because if this hopefully looks familiar, back from right before break, we had to do this thing called inverse trig, or inverse sine, cosine, tangent, to find the angle measure. So this is where you raise it or multiply it by sine inverse. And remember, if you do it to one side, I have to do it to the other. And on my calculator, I'm typing in second sine. And this answer, if you don't want to type in 0.1179, you can press second and the little negative button at the bottom here. That gets us the answer, like the previous answer from above. It'll just say ANS for previous answer, and that way you don't have to type in 0.1179. But if I did, notice it'd be the same thing. It'd be maybe off by a little bit because you're rounding it, but it'd be pretty close. So about 6.77, that's the angle we just found for angle Z. And I know that seems like it's not quite right. I'll round it to tenths. But don't forget degree symbol. That's how we find that missing angle. Okay, so there are more parts to this because you're supposed to find everything, but I just wanted to at least go through just to find measure of angle Z, because I wanted to show you one where you want to find an angle measure, because you'll have to do both kinds on homework tonight. All right, so the homework is 8.9, so definitely try that out. If you have questions, just bring it tomorrow. We're going to work on going over 8.9 plus doing one more method called law of cosines to help us in another way, because the only time you can't use law of sines, let me show you when, if I move this up, if I don't have an angle and the side across from it, as one given, I can't use law of sines. Like if I try to do law of sines here, I would do sine of 66, or I think that's 60, yeah, 66, and then I would try to divide it by something, I don't know what that is, and then I would try to do sine of another angle and divide it by 13, for example, but I can't have two unknowns, and that's why law of sines would not work on like number 1. So this, you're gonna have to wait to do this problem set, at least number 1, until after tomorrow. For today though, if you do wanna finish up number 2, you could do that. We're about more than halfway done because you just have to figure out one more angle by subtracting from 180, and you have to find out that last side. You can do law of sines again to help you find this last missing side. All right, so if you want to practice this, go ahead and use this problem set. Otherwise, you can just do the questions from the 8.9 homework, and that's it. And we'll go over this tomorrow.